Hi viewers, this is Dr. Jana and you are watching video with me on implementation of decision tree and random forest classification using this Jupyter notebook of Python. Okay. So in this video mainly we will be focusing on the implementation of the decision tree and also this random forest. Okay. In the decision tree what we do, how many number of features are there or how many parameters are there, based on that we can go for a number of decision tree, right? So these decision tree they works in parallel. Okay, how many a number of decision tree, and we go for the this is, as you know, this is just like a bagging type. So here we will be going for this voting. That means the majority will be taken as only they are the winner, right? So in this way we can go for this decision tree. Now we are going, already we discussed all the things in our video, the theoretical part, and in this video we are going only for the implementations. Okay, so we need a number of libraries for importing this pandas, import pandas as pd, import numpy as np, import matplotlib.pyplot as plt, import cborn as sns, then percentage matplotlib inline, then sns dot set style, that is the dark grid. Now we need one more library, that is the py.plus. So exclamatory pip space install space py.plus, that first you have to install. It takes some time and it installs successfully, and once it is installed you can see this is the collecting all things, but they are building the wheels, and they will be installing all the things and successfully install the py.plus 2.0.2, right? Then once it is installed we go for importing this py.plus. Okay, you import it, so it is also imported successfully. Then we go for from ipython.display import image. Then here we take the database, and I am taking the database income underscore evaluation.csv. Okay, so here the database I have taken from this Kaggle, and it is stored in my user, then desktop, miscellaneous 22, internship, like that. So in some folder I created, in that folder it is created, right? So it is finally whatever the data you read it here, that is stored in df. Is it clear? Now df dot heads, the first 5 rows of data you can check it here, 0 1 2 3 4. So all this data we are having the age, we are having the work class, we are having the final weight, like that, education. So all these things we are having it here, right? So then once it is there, then we can check it if any null value is there. For the df dot is null method dot sum. So if you check it here, we don't have any null value here, so it is fine. Then df dot set, if you go for this one, you can check it. We are having 32,561 rows by 15 number of columns. So the features are 15, right? So then coming to the df.column, we are having the heading like this: age, work class, final weights, education underscore num, and the materials, martial status, then capital gain, capital loss, hours per week, that is working. Then is the native country income, and all these things, whatever things you want to put it here, right? Then you put it here. Then df.column, what are the columns you are having? If you put it here, because df.column already we put all the things, then it will show you the same age, work, all the things what I have given, and the data type is good object it is showing, right? Then df.income.unique. So if you see from this unique, it will divided something that is less than equal to 50,000 amount, or greater than 50,000 amount. So these are the things are there. So once you do it here, you know how to run this. Where control enter, just you run, and you can see the output. It is like this. Then we go for df, now converting income column to 0 and 1. 0 is for salary less than equal to 50,000, and 1 is for salary more than. So we know how to. So df underscore basis income, that is 1 if value equal to greater than 50,000, else 0 for value in df in that income dot values, right? So this is the things we can put it here, and using this also we can put the value. If the less than 50,000, so we put it 0. If it is greater than 50,000, we put it less than equal to it is 0, and greater than we put it only 1, right. Now if you see the DFTEL, so you can clearly see the values here. And now can you see it here? Yeah, can you see? Yes. Then capital gain and all things is there. Now you see income, now it is showing now instead of 50,000 80,000, it is showing 0 and 1. That means it is less than equal to 50,000, this is greater than 50,000. So two category test shown. Fine. So this is also working fine up to this. Then we are going for df dot var class unique. So here if you see in the var class, you just go for this thing. Okay, you say this DFTEL also. You go to the var class. What is the var class? Final education. Okay. You see in the just one. Let me see the var class. Age var class. Yeah. With the private, with the self, all these different categories are there. So to know all the things, so what do we do? So df dot var class dot unique, you once you put it here in the array, it will show what are the different types are there. One is the state government, one is the self-employed, then that is the private, then the federal government, then the local government, self-employed, without pay, okay, honorary, that is the never worked, or on the database object. So all the things it will be showing you once you use this df dot var class dot unique. Then df dot var class, then what I want to do, I am removing some classes from this var class. Okay, so df var class np where df dot var class which is equal to np dot none. So if any none value is there, just you remove all the things. Okay, then df dot is null. Now you once you check it there, so there is no null value, so all it is okay. So all data there, right. So now it is okay. Then df dot drop na axis is equal to in place is equal to true. So this we can do, and var class level is equal to v k for k. So these are the things that you can put it there. Then var class level, if you check it there, already we see state government is equal to 0, automatically is assigned. Then self-employed is equal to 1, private is equal to 2, federal government is equal to 3, local government is equal to 4, self-employed is 5, without pay 6, and never work, that is 7. So all this category it will show. That means instead of this categorical self-employed like that, it will come 1 2 3 4 0 1 2 3 4 5 6 7, right. Then df dot var class which is equal to df dot var class dot map var class level. So this you can do it here. Then df education dot unique. So we have different degrees levels there also. So it will be showing with an array like this: the bachelor's degree, higher secondary, then okay, or higher study, graduation, HS graduation, then 11th, masters, 9th, some colleges, associate, all the things different type it will also show. Data type equal to object is showing. Then educational level, also it will show df education unique. Then you can see all the things. Now it will assign you bachelor is equal to 0, higher study is equal to 1, or second higher secondary grade it is 1, then 11th is 2, then masters is equal to 3, 9th is equal to 4, like that all things it is assigned, all things 15 category, 16 category to put it there, right. So df dot education dot map education level, so it will put it there automatically. Then we are going to plot. So for plotting, plot figure size, this one income. So now I just plot it here. Okay, so once you plot it here, you can see what it has shown. So data df hue is equal to sex, here male or female, it will show. So that means people who are getting less than 50,000, this is the male and female, and people getting more than 50,000 k, it is dollar or rupees, doesn't make a matter. So it is the male here, you can see it here, and female also you can see it here, right. So all the things is now clearly using this plot dot figure size is equal to 10 by 4. So we can clearly see, understand. See, can you understand? Here 0 means it is less than 50, less than or equal to 50,000. Here 1 means more than or greater than 50,000, right. And blue color is for male, you can see it here, notation. Then the orange color is female, right. Then what you do, the native country is equal to df dot native country value is equal to counts, okay, plt plot figure and all things. Then you can see it here who are the people with the different countries and all things. Here you can see, can you see it is some United States, it is Mexico, it is some country, it is some Philippines, it is Germany, maybe this is India. So like that all these countries you can show with the different color and all things here. So this is the native country. So on the different it will be plotted automatically, there is nothing to worry. Then df dot native country np where df dot native country which equal to question mark np dot none native country. So when something is not known, then in that case we can find it out. Then df dot drop na axis is got in place. So those values is not there, we can drop that also. Then native country is equal to v colon k for k v in enumerate, then df dot native country unique. So if you get it there, you can also get all the things here. And similarly df dot native country, all things we run it here. And finally if you wrote df dot head, you can check it here. The are now showing the age is equal to this one, then war class 0 or 1 whatever things are there, then education different is there, level is there, then education number, then marital status, etc., occupation, relationship, all things you can see it here. And if you see here right hand side the capital loss, all things is also country. Here the country 0 1 also it is showing. Okay, so if it is 0 it is United States, like that all this country, the category value is converted to the numerical value, binary values, right? So this is also done. Then df the marital status unique. If you see different categories of marital status are there, when the never married, married, civil spouse, divorced, married spouse absent, separated, like that different categories are there, that all things it is showing here. Also the data type is object, right? Then marital level also we can see it here, the unique. Then df dot marital status, df dot marital status also, the all the things we can see it here. Then df dot occupation dot unique. So we are having the different type of different category of this occupation, that is administrative clerical, that is executive managerial, so like that armed forces or protective service or craft repair. So all these different categories there. Now df dot occupation which is equal to np dot where df dot occupation which is equal to question mark, when the value nothing is provided there, that we can take it and we can drop it also this value. Then occupation level, all things we put it here. Then df relationship also, that are different categories are there, that we can put it here, not in family, or is husband or wife or one child or unmarried or other relatives, or all things it will show there. Okay, then relationship level also you can check it here, relationship is there. And df dot head, if you check it here, you can find age, work class, final weights, education number, so marital status, then occupation, relationships, all the things we can find it here, right? Then df dot sex and where df dot sex is equal to male is equal to, we are putting male is equal to 1 and female is equal to 0, it will be also 0. So instead of male female it will be showing 1 and 0. Then df dot race unique, here array, different races are there also we are having, because when we want to know what are the different type of things are there, we are putting that dot unique method. Okay, in this unique it is showing white, black, Asian, Pacific Islander, like that, Eskimo, others, that type is equal to object, right? So race level, all things also it is given. Then race level, if you read here, you can find all these things here. White is equal to 0, black is equal to 1, Asian, all this value will be assigned, and instead of all this categorical value, we can have 0 to 4 5 values will be there. Then df dot race, df dot race dot map race level. Then if you check it here, df dot head, you can see it here, df, no race, you if you come here to the race, contest country, country, capital loss, hours, sex, race. So race also it is showing 001 American, like that it is also showing. Then we are going to plot the figure, these things. Once you plot the figure, you can clearly, this is the heat map. From this heat map you can clearly understand. Then we are going for the df dot head. You can see minimum 5 values will be there. It's fine. So then for feature in final weight, the capital gain, and all these things also we can plot it here using this command, and we can see here all the things it is given here. Okay, this and this it is given. Then df does describe. If you see it here, it is showing clearly how many number of rows and columns and everything it is showing clearly. Then from sklearn.model select import train test. So this is the train test split. We need some around 70 to 80% the training data and 25 to 30% also as the test data. So these things x is equal to df iloc given, and y also it is given, and x is equal to x dot value and y is equal to y dot value. So sc the standard scalar. Okay, so sc is equal to standard scalar method, and sc dot fit transform flow also, everything is assigned. Then what you do, xtrain, we divide the data into train and test, and the size you have given 0.3. So training data will be always more than the test data. Here 70% is the training data and 30% is the test data. Okay, this is for validation. So then we use the sklearn.free import decision tree classifier, because we are going to apply this decision tree classifier. Then from sklearn.ensemble import random forest, because random forest is an ensemble technology of decision. Decision tree is one decision tree. So here your forest means a number of trees will be there, and this number of trees also they can work. Okay, so this is the thing. Here it is ensembling technology what you are using in the random forest classifier, but there individual trees are there, they work parallelly, right? So then from sklearn matrix import classification. Okay, that is for this confusion matrix. The D tree, that is the decision tree classification. Then D tree dot fit whatever the splitting of the data train and test, so it will fit to that model. Then prediction underscore dt d tree dot predict x underscore test. Then print confusion matrix y test and prediction dt. Then print classification. So all the things it will be done here. Now from sklearn import tree. Now text underscore representation, which is equal to tree dot export underscore test d tree. Then print this one, whatever things we assigned here. Okay, so with these things we can clearly see now the tree, whatever things we are seeing, the features we are taking 10 less than equal to this one. So feature 5 less than equal to, so all this value automatically is showing here, right? So this is the tree, it is generated here, you can see it here. Fine. So now next we move. Fine. Yeah, so this is the thing, it was there. Then with the open decision tree dot log as found. So if out write text. Okay, this is there. Then figure plt, this also you can draw it here, but it is showing some error, that name clf is not defined. Then we can use this command also. The same thing it is there, because here some extra line we are giving which is not defined. Here I am simply writing field dot true. So now you can see the clearly the decision tree, right? The tree like structure is there. Then tree plot, if you need to plot these things, tree dot plot tree underscore tree. So once you run it this program, you can clearly plot all the things. Okay, so these are the things about the decision tree and all things. Then what we do, then df dot feature names. So what are the feature names? You can write it here. It is showing some error, so it's fine. Then what you do, then df dot feature dot names. Okay, x underscore train, the training data, these are the data we are using for training, x train. Okay, then I am using the RFC, that is the random forest classification, that is the n estimator is equal to 200. RFC dot fit, whatever the split and things we made train and test, so it is fit to this one. Then RFC predict, that is the RFC dot predict x test, against this test it will predict. Then print confusion matrix y test and RFC predict. Then print classification report y test and RFC predict. So these verses, and it is successfully done. You can see the people less than 50,000 and more than 50,000. So the precision, it is coming 88% here, right? Can you see it is 88%, and here also it is showing 70%. The recall is 0.93 and here recall is 0.63. Here F1 score is 0.91, here it is 0.69, and the support is this one. So you know it because already I told you that we already divided the entire data set into some test and trend data. So then we can calculate the accuracy here also. The accuracy here it is coming in FN score, it is 0.85 here also for this much of support. Then macro average also we can find the precision, recall, F1 score and support. These are the measures. These are the things for measuring all things, right? Then weighted average also we get it there. Then so this is all about our decision tree and the random forest classification. So fine. So I hope this code you can practice also in the system, and you will be able to clearly draw a decision tree like this, where we can predict things perfectly. Thank you for watching this video. If you do like this video, please do share with your friends, and also don't forget to subscribe this video. And thank you once again. Please take care of your health, and have a good day.